Welcome to This Explainer. Okay, so today we're diving into something a little wild. We're going to explore the hidden, completely oily forest living right on top of your head to uncover a really fascinating biological true crime story. We're zooming way in on the intricate and honestly pretty messy relationship between our bodies and the billion-member microbial colonies that call our scalps home. So here's a crazy stat for you. This condition, it affects about 50% of the entire human population, half of us. That makes it an incredibly common, yet completely misunderstood microscopic event. You know, we might like to think of ourselves as entirely independent individuals, but biologically speaking, we are vast walking colonies. And for half of the people on Earth right now, the activity of just one specific member of that colony is actively triggering a very visible, very physical reaction right on their heads. So, why exactly do our scalps flake? Well, we're going to investigate exactly that, treating this everyday annoyance as a thrilling mystery happening right within the microbial colonies of our skin. Instead of just brushing it off as a simple cosmetic nuisance, we're going to look at the exact biological mechanisms at play, like what's the trigger? How does our body react? And who exactly is the culprit causing this whole cascade of cellular events? All right, let's introduce our prime suspect. Meet Malassezia. This is a type of yeast that moves in and makes itself right at home in the tiny cavities of our hair follicles almost as soon as we are born. Yep, literally since day one. It evolved specifically to consume our skin's proteins and oils. So it isn't some foreign invader that you catch from someone else. It's a totally natural, lifelong resident of the human microbiome that absolutely thrives in the rich environment of our hair follicles. Now, you might be wondering, what's the motive for this microbial takeover? Well, our scalp is actually one of the oiliest, yeastiest places on our entire body because it secretes a massive amount of sebum. Sebum is this oil produced by glands inside our follicles, and its intended purpose is just to lubricate and strengthen our hair. But for Malassezia, this abundant, oily forest is an absolute paradise. The scalp provides a constant, endlessly renewing feast, giving the yeast literally everything it could ever need to thrive. Okay, so here is the exact mechanism of the crime. Sebum is made up of both saturated and unsaturated fatty acids. Saturated fats, they pack together really neatly. Unsaturated fats, however, contain these double bonds that create a distinct irregular kink in their structure. Now, to eat the sebum, Malassezia secretes an enzyme that releases all of the oil's fatty acids. But here's the catch. It is an incredibly picky eater. It only consumes those neatly packed saturated fats, and it completely ignores the irregularly kinked unsaturated ones. And those leftover, jagged, unsaturated fats, they don't just wash away. Because of their irregular shape, they act almost like microscopic crowbars. They soak directly into the skin, pry the protective barrier of the scalp wide open, and cause precious water to leak out. This physical breach of the skin's defense system is the direct result of the yeast's super messy eating habits. Enter the immune system, acting as the body's internal security force. It detects the structural breach and instantly responds defensively. The body realizes, hey, our barrier is compromised and water is escaping, so it launches a full-on inflammatory response. And this inflammation is exactly what gives dandruff its signature irritating itch. So that itch isn't the fungus biting you. It is literally your own immune system sounding the alarm that your skin's structural integrity has been compromised by those leftover fatty acids. Normally, our skin's outer surface, the epidermis, completely renews itself, totally invisibly, over 2 to 3 weeks. Epidermal cells divide, move outward, die, and shed as single cells that are way too small to see. But to repair the sudden damage caused by the yeast's leftovers, our skin basically hits the panic button. Cells proliferate rapidly, turning out much faster than usual. And because they don't have time to mature and differentiate properly, they stick together. They form these large, greasy clumps around the hair follicle that eventually shed as highly visible flakes. So how do we stop it? Well, currently the most effective treatment for this overreaction is targeting the root cause. By applying antifungal agents, which you'll typically find in specialized shampoos, directly to the scalp, we can eliminate our prime suspect, the yeast itself. By reducing the population of Malassezia, we reduce the amount of enzymes secreted. That stops the release of those barrier-breaking unsaturated fats, which ultimately halts the rapid, panicked clumping of our skin cells. But here is where the plot really thickens. Despite the fact that Malassezia colonizes absolutely everyone to a similar extent, and its food source naturally varies with our hormones throughout our lifetimes, scientists are still trying to figure out why only some people are actually susceptible to this whole flaking cascade. Do some of us have a genetic predisposition? Is the skin barrier of some individuals just naturally more permeable? Are those with dandruff losing more water through their scalps right from the start? It's an ongoing investigation. As researchers dig deeper, they're finding that this relationship is highly, highly complex. Right now, they're investigating these tiny oily communication molecules called oxylipins. Get this. Melastia actually uses these oxylipins to literally talk to our immune system and regulate the inflammation. The current medical hope is that if scientists can figure out a way to inhibit the specific inflammatory oxylipins while boosting the anti-inflammatory ones, they can develop revolutionary new treatments that mediate this conversation between our bodies and our microbes. And scientists now hypothesize an incredibly cunning twist to this entire process. By causing this damage, triggering the inflammation, and forcing the rapid, greasy clumping of skin cells, the yeast might actually be engineering its own environment. Think about it. The resulting dandruff, while definitely uncomfortable and embarrassing for us, practically guarantees a constant, reliable, and highly oily food source for the yeast to just keep feasting on. But hold on, before we totally cancel this fungus, it is vital to look at the bigger picture here. Dandruff is not contagious, and it's not a great threat to our health. In fact, this yeast actually acts as a fierce microbial bodyguard. Seriously, Malassezia absolutely excels at defending its territory, which is our skin, from other truly harmful invading microbes, like Staphylococcus aureus, which can cause severe staph infections. So this brings us to our final lingering question. Is this embarrassing, itchy, flaking simply the rent we pay for microscopic protection against far worse biological invaders? I mean, while scientists have mapped out the mechanism of the crime perfectly, from the sebum enzymes all the way to the rapid cell division, the ultimate evolutionary reason for this relationship and why it affects some more than others makes this entire biological true crime story an enduring head-scratcher. Thanks so much for joining me on this explainer, and keep questioning the incredible microscopic world around you.